All right. Well, welcome to Programming and Driving Your Robot Over the Internet. Thank you for coming. This is being presented by FRC Team 2220 Blue Twilight. In chat, maybe you can enter your team number so we can get a little bit of an idea of where you're from. And we will introduce you three helpful and easy ways you can actually drive your robot and program your robot over the internet that will surely be game changers in your team if they are correctly implemented.
Hi, I'm Steve Siirila. I'm a coach and a programming mentor for Team 2220 Blue Twilight. I've been a mentor since 2007 when our team initially started in FRC. I do work at the University of Minnesota. I have a background in programming, as in particular related to TCP/IP networking, which is what we do in FRC.
Hi. My name is Ethan. I'm the lead student programmer of Team 2220, and I am a student at Egan High School.
I'm John Peterson. I'm an engineer and another coach of Team 2220.
Now, as many of you probably know, COVID-19 pandemic has severely affected many of our robotics teams, and especially caused things like social distancing and safety restrictions, which has limited the staff and on-hand members, especially at our school, where we do not physically allow more than 2-3 students on site in the building at the time. Now, this is especially problematic because programmers want to upload and test their code on the robot, and especially team members who want to drive and test the robot for more experience.
So as we go through the presentation, you'll see that we start out in what most teams would understand as the standard way of interfacing with a robot from their driver station, and we progress into a more complex solution involving a VPN, a site-to-site VPN. One of the first solutions that we deployed was using software called VNC, which stands for Virtual Network Computing, where you share a desktop from a computer over the internet to one or more participants. That has allowed our programmers to be able to use the programming interface and actually download code to the robot. We'll get into more of that in the upcoming slides. And then we will progress into additional capabilities involving actually driving your robot, the possibilities that are there. And finally, we'll get into the more complex site-to-site VPN where additional hardware is required.
Now, from experience, this is basically the most basic step or most basic phase of every team's start. Most teams started this, and they will later develop into higher phases. But for now, in this phase, the driver station laptop is just used for operating and programming the robot. And the driver station mainly is connected to the robot using a wireless connection, Ethernet tether, or a USB tether. And basically, the driver station is only used specifically just for operating and programming the robot. There isn't much other involvement but the driver station. But then you add the second phase, which is basically same as the previous section, except the difference is that the driver station laptop must be transported between the robot and programmer site, which means physically moving the driver station to somebody else's house so that they can program it. This allows programming changes to be finished prior to testing on site with your team, and it also makes on-the-fly code changes and debugging nearly impossible because of the movement. But then you get tricky, and you actually add video conferencing to the situation. Now, from now on, we're going to be using Zoom because it's we used it for our video conferencing software. Now, from there, we actually use teams actually use what is called a repository, and they'll use things like GitHub to store and share robot code all over the internet, which allows multiple programmers to make code changes locally or remotely. But this also means that code development and testing still requires one person at the robot site, and the driver station must remain at the robot site as well. So if any of you could answer the question, how many of you are still using GitHub?
And you can answer in the chat.
Couple of people.
Well, good. So at this point, our team found a way to allow more capabilities for remote students. In this phase, we've introduced software called VNC, and using that software, you can run all the applications you're used to running on the driver station from any remote computer that supports VNC. So for example, your programmers that either use LabVIEW or VS Code for Java, or the driver station, any of those things can be operated remotely through what's called the VNC Viewer. The driver station remains at the robot site, and it runs what's called VNC Server. To do this requires a second Wi-Fi interface on your driver station. The way we do that is with a USB dongle, where one of the Wi-Fi interfaces connects to the internet, and the other one connects to the robot, and that's done at the robot site. And as I mentioned, the software is called VNC, Virtual Network Computing. Yes, the server runs on the driver station. The client runs on as many remote student laptops as you wish, really.
Now next is the next way that we actually found a way to add a little bit more involvement for those who are remote. So in this phase, we actually allow each person to have the ability to control the movement of the robot using either keyboard controls, shuffleboard, or smart dashboard controls using mouse. However, because of this, robot code changes are necessary to support either of these methods. And the only downside of this is that there's no ability to utilize USB devices like joysticks or Xbox controllers remotely, but I'll get more onto that later. Now, now in this slide, we actually fix that problem by going through. We actually fixed the previous USB problem by extending a VPN to allow us to connect to the driver station physically from one driver station to an on-site driver station. Now this allows drivers to use the actual driver station laptop that they would use in person. It also allows remote driving using standard USB devices like your joysticks and your controllers, but it requires additional hardware, such as Raspberry Pi computers. It also requires additional software like the Raspberry Pi operating system and the OpenVPN. And then, but in this phase, robot connectivity is severely limited to Ethernet tethering, which means that each Raspberry Pi, which is connected to each other, will have to tether physically to the robot radio. And that's in order to control the robot from a distance. But I will also get more onto this later.
So if you could answer in the chat, does your team have experience using the Linux operating system? And the reason I ask that is when you use the Raspberry Pi in this way, you'll be installing the Raspberry Pi operating system, and it's basically a Linux-based OS. And we have yes and a no. So I would expect that many of you may need additional help, and we have a folder at the end of this presentation, various installation documents, helpful how-tos that we can't get into in detail in this presentation. So basically what you do is install the Raspberry Pi operating system and the OpenVPN software, which are freely available on the internet. And you write the Raspberry Pi operating system image to your SD card that goes into the Raspberry Pi. And then setting up that Raspberry Pi is pretty straightforward. When you power it up with that SD card and you've got your HDMI monitor, keyboard, and mouse, you can go through and set things like your time zone and your English versus other language kind of things. Pretty straightforward, probably takes less than 5 minutes to do. Once you've gotten to that point, it involves bringing up a command line interface similar to the command prompt you would see in Windows. And at that point, you can install the additional VPN software that's required. And one of the documents that we'll provide you with later will give you a template to use for the configuration of the OpenVPN server and clients, the 3 different Raspberry Pis that you'd be setting up. And you'll probably use an editor of your choice, such as the VI command, to set those up. It should be noted that the OpenVPN server that you choose needs to be on an IP address that's publicly available, which we'll get into a bit later. Even better if you've got a static IP address, which makes things easier. And then finally, there's some bridging scripts that you'll be installing on the client Raspberry Pis to bridge the physical Ethernet jack with the VPN to allow your driver station and your robot to be joining that network. So getting a little bit into the VPN server setup, at your first Raspberry Pi, you will install this necessary software, configure it. You can use either the wired Ethernet or a Wi-Fi interface because you won't be doing any bridging on this particular Raspberry Pi. We'll be showing a diagram in a few slides of how this is all set up. As I said earlier, it requires a publicly accessible IP address on your server so that the clients are able to reach that server and make the VPN possible. You'll also have to set up what's called port forwarding on the router in that location to direct the UDP packets that need to come in to the router to basically direct those packets to your Raspberry Pi. If your IP address changes, which is most often the case for most of you, if you were to, for example, set up the server in your house, you will need to reconfigure the clients at that configuration each time it does change, whereas you wouldn't have to do that for a static IP. And let's see, node servers, yeah. Rest of that slide self-explanatory. So now that you've got your VPN server set up, you have your clients that you need to set up in each site. One of those sites is a robot site. Again, there'll be a template available that you can use to configure that particular client, the one at the robot site, which references the public IP address of the server. You'll configure a bridge interface on this client to bring the VPN together with the wired Ethernet. And in this phase that we're at, we're assuming that you're tethering your robot. So you would connect your Ethernet cable from that Raspberry Pi to the robot directly. And then finally, you have to make sure that your Wi-Fi interface on that Raspberry Pi is configured to access the internet using the appropriate SSID and passphrase.
Now, after you've got your VPN set up, you may wonder how you may stop your robot if it somehow goes out of control. Maybe there's a wireless connectivity issue, and here are a few answers. So the first answer is actually mainly for the remote driver, but you can just press the space bar, which is how normally teams normally emergency stop a robot. But the second option is for those who are actually by the robot or the client, which is that they can either disconnect the Ethernet cable from the Raspberry Pi or the tethered case, or by disconnecting the Ethernet or power cable from the robot wireless router, which will both allow a quick and fast e-stop for the robot. Now, as you move into the next phase, tethering may not be your favorite thing to do. So this is for those who want the additional step. In this phase, you actually, it's basically the same as the previous section, except the difference lies in the additional wireless router, which allows wireless connectivity for those by the robot. So essentially, you connect the Ethernet cable from a Raspberry Pi to a wireless router. And that additional wireless router that you have purchased will need to be configured with an SSID and a passphrase of your choice. Now, more information on how to configure your wireless router specifically for this purpose will be added in documentation. And finally, the next thing you'll need to configure is your robot radio to be in FMS off-season mode with the SSID and passphrase you have chosen above. So let me show you how this works. So you start off by setting up your VPN server site. Now basically you set up a Raspberry Pi VPN server, which connects to your router, which then connects you to your ISP and into the internet so that many things can access it. And then the next step is to get your robot station set up on the other side, which again, you use a Raspberry Pi robot VPN client to connect to a wireless connect to a wireless router, which allows connection to the internet. And the next step after you set up this Raspberry Pi VPN client is to then connect it to your robot. Now this can actually be done in the two ways I've mentioned below. You can either use a tether or you can use the wireless router, which directly connects to your robot radio. Now with this connection to the robot radio, it allows you to physically connect to your robot reel and any cameras you have installed, just in case you want the person on the other side with the driver station who's controlling it to see what they're doing when they drive the robot. And then finally, you move on to the last step, which you actually set up the driver site VPN client. Now you also use a Raspberry Pi for the final time, which will connect to your driver station. Now, basically, this orientation allows the driver station to connect to the VPN network, to the wireless router, to the internet. And once it's connected to the internet, it will flow through the VPN all the way down to the robot site. And through that, the robot VPN client can read the signals coming from the driver station, and you can actually control everything that was mentioned in the robot. So you're given multiple different services, like the driver connection to the driver station, other services, and more.
Yeah, and because this is the internet, the driver station VPN client, that can be set up anywhere, as can the VPN server. The only thing that has to be physically with the robot is the robot VPN client.
So you might wonder what kind of hardware is necessary. This kind of gives you a rundown on kind of the minimum, $180 or so, which involves the Raspberry Pi itself, along with its power supply and SD cards for each. And we would recommend that you probably go with a wireless solution, which is going to run you more around the $250 range. The Raspberry Pis themselves need to be at least a Model 3B plus or higher, which gives you the added capabilities that we utilize. And frankly, we didn't test anything prior to that version. So your options are either the Raspberry Pi 3B plus or the Raspberry Pi 4. And yes, the power supplies that come have to have a 2.5 amp minimum as well. The SD cards can be gotten pretty cheap these days, especially if you get the lower 8 gigabyte. I know they go up to 64, 128 gig. That's not necessary. You won't need a lot of extra storage on that card. So they can be had for $10 a piece. And then finally, you will need some sort of HDMI monitor, HDMI cable, a USB keyboard and mouse, if nothing else, to get the Raspberry Pis initially set up. Once you've got them set up, if the Wi-Fi network doesn't change and the server IP address isn't changing, you should be able to just bring up those Raspberry Pis and they should just connect and everything should just work. But you may occasionally need these three things for doing setup or doing changes to the configuration. You'll also need to make sure you have a wired Ethernet port on your driver station, like you would in a competition, or a USB to Ethernet adapter. And then, of course, access to Wi-Fi at the client locations. Here you can see our testing that we performed at our school. In the background, you can see the pylons that made up our test course. And in a moment, you'll see the actual driving of the robot being performed remotely.
Now, in this scenario, I was the driver, and you can actually see my hands at the top left and the driver station at the bottom left. As you see, the left camera is actually the front of the robot, and the right camera is the back of the robot as I pass through the cones. Now, the process to set up the VPN was very easy, and I didn't have to do much work. And the only problem through this process was the slight packet loss and minimal ping, which did cause minor delay, but for the most part, I didn't even notice it at all.
It's probably a little bit slowed down because we were using the cellular network. We probably wouldn't have had those problems if we were using the school's Wi-Fi network. We just wanted to do worst case testing.
And you'll notice in the lower left corner, we have two USB cameras mounted on the robot. So he's got a forward and a reverse view.
Yeah, there's plenty of bandwidth to do the two cameras and run the robot.
And then we use the Zoom session generally for a wide angle. So in this footage, this is the same footage.
Same one.
There we go. In this footage, you'll see a very short video just showing our robot's ability to shoot balls as he manipulates the controller there. And so that just illustrates the fact that, yes, we can drive remotely. We can manipulate the various things on our robot, like shooting. We didn't have any other videos showing the other capabilities, but
and the lag for controlling the robot, as you may have seen when I was shooting, was only about 100 to 200 milliseconds, 0.1, 0.2 seconds, which is not much. You don't really notice it unless it gets into the upper 300, 500, but that rarely ever happens, even in the worst case scenario.
But yeah, we were operating a robot from Ethan's home, just like if he was at a driver station at a competition match.
Yes, we followed up this testing where we were using a Samsung phone for this test with connecting to our school Wi-Fi, which, as you can imagine, was probably, well, it was about 50 to 100 milliseconds, as I recall. So about half what you see here on the screen.
As Ethan said, you really can't notice the lag, even with the cellular network.
Now, finally, in this phase, you actually utilize two goods. Now, remember in the last category where we told you about VNC Viewer. In this phase, you use the VPN network to connect to the robot at the robot from the driver station, and you use the VNC Viewer to allow multiple viewers to chime into the driver station, which is controlling the robot remotely. Now, this allows multiple drivers and programmers to view the driver station laptop remotely. However, the only problem with this is that viewers have to take turns controlling the driver station, and the driver station, and it requires a driver station wireless interface to be enabled in order to allow VNC servers to be reached by others.
So this is where we're at today. We're able to do everything that we've described up to this point. What we're looking for the future is to potentially go from 3 Raspberry Pis down to 2. The reason we chose 3, we have a static IP address location available to us, and unfortunately that site is not suitable for a robot, and students are not at that site. So that's essentially our VPN server site. In another scenario, you might find that you have static IP address capability at your school, for example, or at a warehouse. If that's the case, your VPN server could theoretically be configured as taking on the second role of being the robot VPN side. In that scenario, you'd only need 2 sites, the robot site and the remote student site, wherever that might be. So that's not something we've actually done, but in theory, it should be very doable, and it would result in lower cost. Another option that we've been looking at is expanding from a team-specific VLAN, or not VLAN, a VPN, where you basically have your team's robot and only your team's robot, to a multi-team VPN configuration, which would allow multiple teams and multiple drivers on a single VPN, which introduces the possibility of having standard 3-on-3 robot matches that you're used to seeing. For example, in a week 0 event, we use FMS software. And so we're looking at what options might be available there to do some of that remotely. Of course, you'd need robots on site and possibly a set of coaches or whomever is able to be at that site to manipulate the robots in whatever way they need it to be. And then finally, we've been looking at ways to potentially use this VPN setup for use with FTC, because everything up to this point that we've discussed has been for FRC. So yes, as you can imagine, FTC has the same issues with remote driving as we've had during the pandemic, as does FRC. FTC uses a technology called Wi-Fi Direct, which is slightly different than what we're used to in FRC, and that's done between 2 Android devices. We were looking at ways to utilize our VPN solution in conjunction with the Android phones talking Wi-Fi Direct to, say, routers that are on our VPN. More work to be done there, but that's something we're looking at. Finally, we have others in the FTC area of Egan Robotics that have been testing and working with something called Teledrive, which is linked here on this slide, a couple of different links. And that sounds like a promising solution as well. It involves a different method. It doesn't involve a VPN, but it involves drivers using a laptop to control their FTC robots. And so you can go to that link to find out more information about that. So with that, we're done with the main part of our presentation, pretty much most of our presentation. If you have any questions, this is the time for them. You can either ask them verbally or in the chat. And I'll go back and look at the chat out here a little bit, see if I can find some of the questions. Is VNC similar to Team Viewer? I'm not familiar with Team Viewer, but I would imagine it is. It's VNC is a way of sharing oftentimes a Windows desktop completely with one or more remote participants. We have instructions in the links that are upcoming here for setting that up. But essentially, if you can imagine yourself at a desktop, being able to do pretty much anything, clicking the mouse, typing on the keyboard, whatever. It's not going to translate USB devices, but other than that, you can basically operate that computer remotely. And if someone were at the site where the server is running, they could actually see all your mouse movements and your typing as they are doing it on the remote side. So it's a pretty cool technology, and it's what we've been using probably over the last 3 months or so, and it's been our main way of involving our programmers. So they've really enjoyed that capability. Well, the one thing they haven't been able to do up until recently is actually be able to download. Actually, they're able to deploy code to the robot by way of us at the robot site doing it for them. But with the VPN solution, of course, you can go further with that. I hope that answers your question about VNC in general. I know you're asking about Team Viewer. I'm not familiar with that. I don't know if anyone else is. And hardware specs. And there was a question about hardware specs, and I think I addressed those in the hardware requirements slide. If you have any more specific questions, I can certainly answer those. See, while driving, what is the lag between the control input and the robot output? Well, I can speak to the latency. We mentioned that earlier. We've seen latency anywhere from, down in the 30, 40 millisecond. And the worst case, with a functioning driver robot scenario, even up to 200-300 milliseconds, it starts to become noticeable if you're getting up around the 250-300 millisecond range. But Ethan can speak to how well he was able to drive even using our cellular phone, which runs, I think, around 150 to 200 millisecond.
Yeah.
So how was it as a driver for you, Ethan?
It was minimal lag, and I could easily control the robot. I mean, if I was able to do that, I mean, I'm not really sure to call it an obstacles, but that obstacle course, then it should be pretty. It shouldn't be too much lag for anyone else.
Let's see, any other questions? Have you talked to FRC or FTC staff about this? At this point, some people are aware of it. We have not talked anything in particular about where we would go from here. This is kind of I'd say we've been using this VPN setup and had it successfully tested for what, the last 3 weeks, would you say?
That's about right. We've been continuously doing that testing and trying to break it.
Let's see, can we get a link to the installing and quick links in chat? Yes, we have a few slides coming up here that we can go through. One of them is the one in particular that we'll show you. It's this link on this page. So if you have any questions after this presentation, you can certainly contact us at our team email address listed. And the materials for setting up VNC and VPN and the other things that are required as part of it can all be found at the link here, which is essentially a Google Drive folder link. That's going to look something like this. And this presentation itself is in that folder, as well as some Google Docs on installing your Raspberry Pi and your software on the Raspberry Pi. Some other documents that we didn't cover are also in here, showing things like the robot network IP address assignments, as well as how to set up bridging. If there's something that you find that isn't quite explanatory, again, feel more than free to contact us through our email address. We'll be updating these documents and improving them over time where we find there might be some gaps. But that's what you expect to see. There's a few more documents in there now than what you see here.
This presentation will be uploaded to the Jumpstart site as soon as it's processed. I'm not sure how long that'll take, but it shouldn't be too long. And then you can access and get and see all the links at that time too.
Hey guys, this is Andy from Andy Mark listening in. My background is mechanical design, and I'm a gearhead, not so much a controls guy, but this is very enlightening to me. Our staff here, we've been working on remote control or remote access and control of robots. I know one of our guys has been working on an ESP32 chip on a feather control on Adafruit circuitry that seems to be working. So there's different solutions for this. However, I think this is the first I've heard. This doesn't mean it's not happening, but this is the first I've heard of teams successfully doing this with minimum latency between the control and the output of the robot. I think this is a big deal, and I think that first headquarters really needs to hear about what you guys are doing in order for this to be communicated for more teams. More teams are looking for this solution, and this could. I know that each program within FIRST, FLL, FTC, FRC, each program spent a lot of time this past 6 months working on how to remotely engage all of their teams and have the teams compete. And there's a lot of effort in this. So I think there's been probably some effort put upon the same task you guys are working on. But if you have solutions that are working and you want to share it with FIRST headquarters, I can help introduce you to the right people who work there. I think this is really, really impactful.
Yes, that would be good, Andy. Appreciate that, because yes, we do want to get this upstream as fast as we can, because it seems like something that will really help out FRC, if not FTC too.
I think the first person to talk to would be Chris Rake, and then people that report up through him would be Frank Merrick at FRC and Ken Johnson at FTC.
Okay, great. Thanks.
Good to know. Any other questions?
You want to show some of those other pictures, Steve, of the equipment?
This is one of the documents that gives you another view of the various stages we went through, or I mean, maybe not the first three, but the blue basically shows the introduction of VNC and, the capabilities that are given remotely. The green gets into VPN and Raspberry Pis. You'll see a grade one out at the bottom. We have not actually done that, but we could envision multiple robots on that VPN. Here's a photo of a Raspberry Pi that's actually mounted on a 7-inch monitor. Obviously, you don't need to purchase that. It makes it simpler as we go into our school and we need to make changes rather than lugging a monitor around. We have a small, well, it is a monitor, but the Raspberry Pi fits nicely on the back. I probably should have provided a link to that as well. And I probably will add that to as an optional hardware requirement, not a requirement per se, but if you're interested in that, it is a little pricier. It's I think like $60 or $70. And there's that same Raspberry Pi set up there. You can see the Ethernet cable hooked up to the wireless router that the robot talks to. And with that, I believe that is the end of our slides.
Yeah, Steve's done a lot of great work on here with Ethan in developing this. It took weeks and weeks just to get it up off the ground, and he went through a lot of different stages and everything. Okay, so all the hard work's been done here, and we're using just free off-the-shelf software that you just have to make a few tweaks to and everything like that. And he's got examples of that in his list of files. So you shouldn't be really intimidated by this. Yeah, it's a big thing, but all the hard work's done. So if you follow the directions and everything he has in there, you can get this up and running and working on your system. And not just for your students, but if you're having some kind of open house where people can do that remotely, or even sponsors, you can have them operate your robot remotely, and they love that. They love to actually drive their robots, and this way they can do it.
Another thing I want to give you guys feedback about is the fact that you, I mean, Ethan, good job. I think it's intimidating for a student to make a presentation, regardless of who your audience is. Us adults, we do this a lot, but for you students to come in here and take some courage to put yourself out here, I commend you for your efforts. So good job, Ethan, for being a key part of this presentation.
Thank you.
Yes, definitely. Ethan has done a wonderful job in helping us get this set up on the remote end of things, and great job.
I'm not seeing any additional questions, but I mean, I really appreciate your time, Steve, John, and Ethan. This was very good. It's excellent that all this information that you did present will be available for everybody. So if there isn't anything else, I just want to thank everybody for your participation, and we'll go ahead and end and just enjoy your Saturday.
I have a question, Tanya. When do you think that this will be available to download off the Jumpstart site?
I don't have that information. Let me see if I can find out and try to get back with you.
Okay.
Okay, very good. Thank you.
Thank you.
Thanks.
Bye-bye.